Okay, so predicting products. You're going to have to predict the products of three different types of equations. You're going to have to predict products for synthesis reactions and single replacement reactions and double replacement reactions. We're not going to deal with we're not going to deal with decomposition reactions, and then combustion reactions are always the same. So let's talk about synthesis first. Right, and before we get into word equations, we're going to go ahead and just give you the reactants, the actual formulas for the reactants. So the first thing you're going to do, this is just like our ionic compounds that we worked on a couple of sections ago. You're going to find the charges. Okay, so aluminum is a 3+, oxygen is a 2-. Okay, so find charges, then cross charges. All right, so we have Al2O3, and there's our answer. Okay, it's a synthesis reaction, so we're only coming up with one product. You may ask yourself, what about this 2? Where does that go? Well, that 2 doesn't go anywhere. Your rule is that subscripts across the arrow of a polyatomic ion. Your rule. So because this oxygen is just an oxygen by itself, it's not a polyatomic ion. Its subscript is left behind. It does not cross the arrow because we're making something totally new over here that is apart from the subscripts on the left. All right, so once you've got your product, then you're going to balance the equation. So we end up with a 2, a 3, and then a 4 here. So there's your balanced complete equation. So remember, predicting the product, part of predicting the product is balancing the equation. Okay, it must be balanced as well. Okay, let's do another example of a synthesis reaction. Let's go Mg plus Fe2O3. Okay, now, in the last scenario, sorry, this is a single replacement. Sorry, let's go back. So magnesium plus N2. Okay. So again, we've got a 2 here, and we'll talk about why that is here in a second. So you're going to take magnesium's charge, which is a 2+. You're going to take nitrogen's charge, which is a 3-. Cross those charges, and you're going to end up with Mg3 N2. Write that a little bit clearer. Okay, again, this 2 does not cross over. All right, so when do we need the 2? Okay, and we'll get into that when we get into the synthesis reactions, because right now all we're doing is coming up with one product. All right, so here's your product. Then you're going to just put a 3 here in front, and it's balanced. Okay, so that's synthesis. It's pretty straightforward. It's almost identical to just making the compounds that we were doing a few sections ago. So let's do single replacement. Okay. So in single replacement reactions, you have to know that metals replace metals, non-metals replace non-metals. Okay. And that's important when you're looking at which element is by itself. So if we do one where we have NaI plus F2, and what does that yield? So you have to say, okay, sodium is a metal, okay, and iodine is a non-metal, and fluorine is a non-metal. So these two non-metals are going to switch places. You would not switch places with the metal and the non-metal. Okay? So these two are going to switch places. So what you're going to do is when you have a compound and a synthesis or a single replacement or a double replacement reaction, you're going to break apart the original compound. So Na plus, and then I minus. Okay, and then you have F minus. Well, we've already said that the Na and the I and the F are going to switch places. So these are the two that are going to come together, and then the I is going to be left by itself. Okay, so you have Na plus and F minus. When you cross those charges, you just get NaF, iodine by itself. Okay, and it's I2. All right, so anytime you have an iodine by itself, it has to be it has to have a subscript of 2, and here's why. There's a list of elements that we call Brinkelhoff: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Okay, these are called diatomic, meaning they are never by themselves in nature. So anytime you have them just by themselves, okay, not attached to anything else, so like fluorine here is just by itself, iodine is just by itself, okay, it's not attached to another element, it has to have a subscript of 2. So, must have subscript of 2 when alone, okay? So, and the reason is, we never find them by themselves. You're never going to find just one fluorine atom by itself. You're never going to find just one iodine atom by itself. It's always either connected to another element or connected to one of itself. Okay? So this point right here is very important, specifically in word equations when you have to come up with the entire equation, and single replacement reactions when one of the elements that's by itself might be one of these diatomic elements. Okay? So that's exchanging a non-metal for a non-metal. Let's look at exchanging a metal for a metal. So we have Mg plus Fe2O3. Okay, again, we have a metal here in magnesium, we have a metal here in fluorine, and we have a non-metal here in oxygen. So the metals are going to switch places. So you have magnesium here, and it's a 2+ charge. You have iron here, and it's a 3 charge because we reverse the cross. And then you have oxygen, which is a -2 charge. So you're going to take these two, cross those charges, and that is going to give you MgO, okay, plus Fe by itself. Now, all metals, can just stand alone by itself. Magnesium right here can stand alone by itself without a subscript of any kind. Okay, so again, these subscripts are just left behind. You don't pass them on. You don't move them across the arrow. They stay on the left side of the arrow because that's what this that's what this reactant is. Okay, we have to make totally new products. Okay, so you're going to switch your metals and your non-metals. All right. So let's go to a double replacement reaction. Double replacement reaction is almost easier than a single replacement reaction because you don't have to worry about what the metal is and what the non-metal is and which one should react with what. Let's say we have Mg3PO42 plus BeNO32. Okay, so what products do those make? Well, here's our metal, here's our non-metal, here's our metal, here's our non-metal. Okay, and when I say metal and non-metal, what it can really mean is cation and anion. So yes, PO4 is not a non-metal, it's a polyatomic ion, but it's acting as the anion because it's negative. All right, so what we're going to do is we're going to bring the outside ones together and then the inside ones together. Okay, so we have magnesium, and it's a 2+ charge, and nitrate, and O3, and it's a -1 charge. You're going to cross those charges, and one of your products is going to be magnesium nitrate. Okay. Your other product here, so that's that one. So now we're going to do the inside ones. Beryllium is a 2+ charge, and phosphate is a 3- charge. So you're going to cross those just like we've always done, and you're going to end up with Be3, 2. Okay. So again, here's one example where this subscript in the nitrate and this subscript in the phosphate are going to cross over the arrow because they are part of nitrate and they are part of phosphate. Okay, so these subscripts and these polyatomic ions can have their subscripts move across the arrow, all right, because they're still part of the same entity. All right, so again, we're going to take the outsides and bring them together, and then the insides and bring them together. Okay, kind of like the FOIL method in math. Okay, let's do another example. Let's say we've got, let's see, lithium sulfate plus chloride. All right, so we're going to take our outer elements and then our inner elements and bring them together. So lithium is a plus, chlorine is a minus. Cross those charges and you get LiCl. Okay, bring this one down. You have sodium is a plus, sulfate is a 2-. So you're going to cross those charges and you're going to get Na2. All right, and then you balance it. All right. But there's your equation. So it's not super difficult as long as you remember that, you know, your metals and your nonmetals have to come together. Okay, you couldn't put Li and Na together, all right, because they're 2 metals. One last thing is that when you're doing this, you want to make sure that you do the thing to completion, make sure you balance it, because that's part of it. Remember, another example here, this 2 does not cross over to here, okay, because it's something just totally different, and that's it. So as long as you keep in mind that the metals replace the metals, and the nonmetals replace the nonmetals, make sure you've got things that are coming together that should come together, a positive and a negative, and you should be just fine. Okay, so that is predicting products.